I want to play with a couple of modules today, specifically the OS module, lib/OS, and the sys module. There's probably only one thing we want out of the sys module. But whenever you want to find out something about Python, like I ask you a question on a quiz, you're sitting there at home, you can look up in the internet any answers you want to, and I ask you something about Randant, which library it's in. All you need to do is type in Randant Python 3, since we are using Python 3. You'll probably be taken to a site on Python.org as the first hit. You might get Stack Overflow as the first hit. Millions of questions asked and answered on Stack Overflow. So this pretty much the centralized depository of programmer knowledge anymore. Anyways, so we look it up. We find Randant, and we see that it's in the random module. So ought to be pretty easy to find something like that. And if you look around, you can probably find some examples, like if you scroll down here. Yeah, get some examples of it. Just as a rehash, I need to turn the light down a little bit more. Just as a rehash, you can call .random, you get a number between 0 and 1. That's a little too dark. If you call rand_range, it generates a number between the specified range, which is pretty cool. Like if you're trying to get a number between 1 and 6, that's pretty easy. You would do rand_range, but you'd make it between 1 and 7 because this upper number is one past where you're trying to go. The library is a little bit inconsistent about whether the second number indicates the end point that's inclusive or exclusive. Randant, it's inclusive, so if you wanted to generate, a number between 1 and 10, then you would put 1, yeah, if you want to go from 1 to 10, you'd put a 1 there and then a 10 there. But rand_range, you'd put a 1, comma, and 11. And honestly, as I look at this, I don't really see a difference between Randant and rand_range, except with rand_range, you can specify, that you want numbers, only even numbers, or only numbers that are divisible by 3 or by 10 or whatever. That's just a step. Rand_choice will return a random element from a list. Rand_shuffle will shuffle a list. So if you arrange a list and then you call rand_shuffle, and then you print out the items, you'll get that. And then random_sample, you give it a list, and then you say how many elements you want out of it. Like if you're writing a poker game or something like that, you have a list of 52 different cards or whatever. Then you call rand_sample, and you say I want to get 4 cards out of it, or 5, sorry, or you get 20 so that you can get 5 to each player, something like that. Anyways, I feel like kind of playing with random.shuffle just real fast because it has to do with lists. So you don't particularly have to type this, but if you feel like it, that's fine. So if I did this, cards is equal to, and then I'm going to, between my square braces, put, Jack, in quote, comma, queen, comma, king, comma, ace. And then I might put all the other cards too, right? 2 through 10 or whatever. I'm just going to put a few of those. 10, 9, 8. That's about enough, right? Okay. So I have a list of cards. Well, I want to use the random library. So I'm going to do import random. Now I can shuffle them. Random.shuffle and give it the list. Then I can print my cards out. Excuse me, I called it cards, not card. Now I'm going to print my cards out. And so let's save this. Make sure I don't save it in the Python directory. Make sure I go, my favorite scripting directory. I don't even know what lecture we're on today. Looks like we're on I. Are we?
We're on J.
We're at J, thanks. All right, so when I run it, we'll see that they're in a different order than they were before, right? 9, king, 8, queen, ace, 10, jack. And if we wanted to write some kind of card game, we might remove cards from the end of the list and create another list that held those cards, something like that. It'd be fun. I may be thinking about a project that has something to do with, with a card game like that, and add it to the list of possible projects for you to do. So if I have this card, excuse me, if I have this library, notice the connection between this and this. What if I don't want to have to type random dot whatever, like, if x is equal to random dot rand int, and I want a number between 10 and 20, whatever. I'm having to repeat this word over and over in order to get that to work. What if I just want something shorter? I can do this, import random as R, and then whenever I want to shuffle, whenever I want to call one of those functions, I can do this. This is renaming the module. It's kind of aliasing the module. I'm saying, I got that. I want to import it as R, so I can do that. Now, I hope I didn't just botch this. Let me see if I got an error or not. Okay, it's still working, right? So I could do that if I wanted to. And maybe in the future, when I give people turtle examples, I may just import turtle as T or something like that. The other thing you can do is you can import specific methods, specific functions from the library. From random import shuffle. All right, now I've brought in a specific function. I can just call it like that. What if I want Randant as well? From random import Randant. All right, there. Now when I run it, hopefully it does the same thing and I didn't break it. And why would you want to do this? Well, you get tired of typing random dot all the time. I kind of don't mind seeing the word random in front of all these functions because it makes it real clear where they came from. What about, I'm pretty sure there's a math library that's got pi in it, Python, math.py. Looks like there's a function called, well, I don't want to do it that way. Anyways, math.py. So I could do that if I want to play with pi, import math, and then I'm going to print math.py. Right? Get that going. Whatever. We get a nice, looks like what other languages would call a double. A double is a 64-bit version of a floating point number, so it has quite a few decimal points that it can keep track of. Decimal places, excuse me. So I could use the same syntax here. From math import pi. And now I don't have to type math dot in front of it. And again, I don't mind typing math.py, but you'll see this syntax a lot. And as a matter of fact, when I Googled Python math.py, the very first example had from math import, right? You can import more than one function at the same time. From, math import, and here they're giving an example of importing two functions from it. So here, where I did two imports in a row, import shuffle and Randant, I could have done this, import shuffle, comma, Randant, like that. Then it would work just as well. I do not believe that you could use a wildcard there, but let's find out. Import everything, please. And it worked. Okay, cool. What do you know? I learned something. So you can import everything from a library by doing that. That's kind of neat. You don't have to specify them. On the other hand, there's nothing wrong with specifying them up at the top because that gives somebody else the ability to look at your code and understand at a glance what it's going to be using. If I did from math import star, I don't know which functions I'm going to be doing. So now that we're on the topic of math dot, I want to look at some of the functions here. There's ceiling, Return the ceiling of x as a float. The smallest integer value greater than or equal to x. So if we did this, print the ceiling of 5, it's going to say it's 5. But if it's 5.01, it's going to say it's 6. Or not. Well, I didn't do from math import. Right. Okay. Comma seal. There we go. Import math comma seal. All right. What is it doing? It's effectively so-called rounding it up. Right? 5 rounded. Well, 5 is exactly 5, so there's no rounding needed. But 5.01, if you were normally going to round it, you know, the way we colloquially use the term round, we mean round it to the nearest whole number, and if it's past 0.5, it'll round up, and if it's lower than 0.5, it'll round down, right? So if we had rounded this, we would expect it to say 5, but we ceilinged it. We rounded it up. So guess what? There's a floor function too. All right, so I'm getting tired of giving my different functions here, so I'm going to change that to import star. So if I do the same thing and I print floor of 5, it's again 5, right? Because 5 rounded down is 5. But 5.9999 rounded down is also going to be 5. So floor rounds down, ceiling rounds up, and then there's just a flat-out round function, which does what we normally believe, right? 4.6 would round up to 5, 4.4 would round down. And it's kind of nice because you can specify how many digits you want it rounded to. I don't think ceiling does anything of the sort where you can pass in 2 different values. No, but round can. So like if we have pi, print round pi. It's going to say 3, right? Because pi is 3.14159 and a whole bunch of other digits. All right, so that's expected. But if we say pi comma 1, that means 1 decimal after, or 1 digit after the decimal place. So it's not going to be 3 anymore. It's going to be, well, since pi is equal to 3.14, 3.14 rounds down to 3.1. And if we say we want it rounded to 3 places after the decimal point, we can get that as well. Right? And so 3141, well, the next digit's a 5, so it rounds up. Right? And it becomes 3.142. So, second argument specifies the number of places after the decimal point. If you don't specify a value, a number of places, and this is kind of weird. If we did this, x is equal to round pi comma 1, and then we printed the type of x out, it's going to say, well, print the type of x. It's going to say it's a float, and it would have to be, right? Because 3.1, it has a decimal place, it has to be a floating point type. But what if we don't specify a number of places, so we want a whole number? Then it returns an int. That's kind of bizarre. So on a quiz, if I ask you what round parentheses pi is, it's not going to be 3.0. It's actually going to be 3. And it's kind of picky, but it's the way it is. How about this? This is my little question. What if we say comma 0, which is kind of implying the same thing, but it's a float, right? It returns 3.0 because that's what happens if you round it with 0 digits after the decimal point. So that's kind of weird, and I'm not going to ask you what round something comma 0 is, but I think it's fair to ask you what round without any places is, right? It's an integer. Or if I ask you to round something to 2 or 3 digits, hopefully you can figure it out. Hopefully, you know, hopefully in junior high or whatever you learned how to round things. All right. So let's see. We've talked about the random function library a little bit more. We've talked about the math library, ceiling, floor, there's max and then there's min. No, those are actually built-in functions. We don't need to import math. So like if I do this, x is equal to max. Sorry, let me bring this up so you don't have to stretch your head 20 feet in the air to read it. So if I do the max of 3 and 10, x is going to equal 10. If I do x is equal to the minimum of negative 100 and negative 200, well, 200 is smaller, so it's going to be negative 200. I'm going to go back to the math library now. Factorial raises x to the factorial. Hopefully you know what a factorial is. If not, you'll know now. Factorial of 10 is 1 times 2 times 3 times 4 times 5, all the way up to 10. And it's a common programming problem. Write some code that'll calculate the factorial. Maybe we'll do that. Math.isNaN. Check to see if the float is not a number. Well, how do we get a not a number? I think if we do this, 1.0 divided by 0, and then print out x, I could be wrong. Is this going to be a runtime error, or is it going to say not a number? Yeah, all right. I don't know how to get a an NaN. Mod f returns the fractional and integer parts of 5. Both results carry the sign of x and are floats. I'd like to see an example of that because it sounds like it's returning 2 things rather than 1. And we haven't really done that, but you can do that. Now this is going to look a little bit odd, but what if we do this? X is equal to 10. I'm going to put some space here. Y is equal to 20, and this would not work in any other language. A comma B is equal to x comma y. I've never seen another language that supports that, but when it's done, x gets copied into A, and y gets copied into B. So at this point, A is equal to 10, and y is equal to 20. What if you want to swap those values? You could say A comma B is equal to B comma A, right? So B gets copied into A gets copied into B, and magically it all just happens. So at this point, B equals 10, and A equals 20. Now, in every other language I've known, if you wanted to swap 2 values, you would have to use a temporary variable for the most part. You would have to do something like this. Temp is equal to x is equal to y is equal to temp. That's how you do it in C, C++, Java, pretty much every other language. Because you have to have it's like I have 2 values, an apple and an orange, and I want to swap them, but I can only do one thing at a time. I might come over to you, and you'll be my temporary, and I'll give you the apple, and then I'll take the orange and put it in my apple hand, and then I'll get the apple back. Right. So normally that's how you do it, but in this language you're allowed to do things like that. That also means that you can write functions that will return 2 values. In other languages, you have to do something like put them in a list before you return them. Not in this language. If we wanted to, we could write a function. I'm going to write one called, I don't know, just name. And what is it going to do? It's going to return Joe, end quote, comma, Bob. Now, that's not a list. Kind of looks like a list, but if it was really a list, it'd be in square braces. So if I do this, first name comma last name is equal to name parentheses, then by the time it runs, first name is equal to Joe and the last name is equal to Bob. That's kind of cool, actually, because other languages don't let you do that. Why might you want to do that? Well, what if you're going to write something and it's supposed to return a value, but it also may need to return an error code in order to indicate whether it worked or not. Right? You might write a division function, and the division function is going to return the value of A over B, but it might also need to return a value to indicate whether it worked or not. Something like this. Oh well, and I don't want to get ahead of myself. Just know that you can return 2 values, or even 3 or 4. If you wrote something that returned Joe Bob, and Thompson, you know, whatever, the third, you know, so we returned 4 things. We could do that. I have a little question in my head about what happens if we do this. We return 3 values, but we only pick up 2. Is that a syntax error, or does it work just fine? Oh, I still need to get rid of that division by 0. Where was that? Right there. Sorry about that. I have a division by 0. I'm just going to delete that line. And I know I've been going pretty fast, and not everybody's been typing along, but I'm giving just examples of stuff. So just tuck it away. Alrighty, it says too many values to, quote, unpack. Well, I guess that means that when we return more than one value from a function, we are so-called packing it, or it is. And then when it returns, those values have to be unpacked, and there better be enough variables to hold everything that's being unpacked. Fancy term. Okay, so I would have to say, you know, first name, middle name, last name, or something like that to get that to work. I'm just going to delete that. How you would do that in other languages, which I'm going to mention even though we're not learning yet other languages, is you would return a list. You could stick Joe in the list and Bob in the list, you know, and then when you got back, you know that the first element of the list was Joe and the second element was Bob. Or you could get more complicated and create a class and return an object that had those 2 values in it. We're not there yet. Okay, so I have talked about try and except, correct?
Yeah.
Alrighty, so I don't really need to talk about try and except, but I can't think of a good reason to talk about it right now. A quick example, right? X, you know, what we're going to do is we're going to try some math. And so X is equal to, you know, we've got some other variables that we've defined up there, Y divided by 0. But if there's a problem, obviously that's going to be a problem. That's stupid, right? Okay, so 10 divided by Y. If Y for some reason at this point happens to equal 0, then this would blow up. It would cause what's known as an exception. And so we would print an error message, you know, error. Y can't be 0. Whatever our error message we want to print. Now, if we're asking for input, we have 2 choices. Well, we have 3 choices. One is we could kill the program. We could say, hey, loser, I don't know what you want to do, so I'm just going to stop running. Well, that's a valid answer. It's kind of unfriendly. That's kind of like when Word, you know, Windows has encountered an error, and we have closed Word. And well, so much for my document. But another thing you can do is you can loop until they enter a good piece of data. And the third thing you can do would be to set a default, right? So I could put a default here, right? Defaulting the result to 1, whatever. Maybe they don't want that, but maybe sometimes it'd be reasonable to assign a default value. Like if you're writing some code where they're supposed to enter a first and a middle and a last name and they don't fill in the middle, then maybe we would just default the middle name to being, you know, empty quotes, right? I'm not sure how you would know that the middle name was blank rather than the first, you know, than the last name, but maybe they were passing it in from, you know, a web form or something that had 3 blanks on it. So an example of looping until they give us some good data. What we're going to do here, and this is interesting enough in my mind that I wouldn't mind if y'all typed along with it, you know, which is ask for a positive number, or a number greater than 0. So what we're going to do is we're going to loop until they give us a number that's greater than 0. So I'm going to use a while loop. And so what's my number going to be? X is, you know, I'm just going to default it to 1. That's not going to be its final answer. But then why? No. I'm going to default it to 0 so that I can write this in such a way that I can check something like this. While X is less than or equal to 0, right? Because we really want a number that's greater than 0. So while that's less than or equal to 0, we're going to ask them for the number. X is equal to input. What's the number? Or what's the number greater than 0? Question mark. Then we might want to convert it to a float. And if they typed in something that was greater than 0, it would exit the while loop. If they typed in something that was not greater than 0, it would loop. It would ask them again. We could even put an if statement, explaining what they did wrong. But what I would like to do instead, or in addition to this, is to not let it blow up. If they type in something with too many decimal, 2 decimal points rather than 1, or they type some letters in or something like that, I don't want it to generate an exception and crash on them. So for that, I would use a try and an except. Well, here's what I'm going to do. Try this stuff, Mr. Python. And then if there's an error, then I'm going to print an error message. Print, the value must be a number. And then I'm going to assign it a value that would cause it to repeat, right? Because at this point, x equals a string or something like that. They've typed in a string. It was unable to be converted. So why don't we just set it back equal to 0, so it's no longer a string, and that would cause a loop. And then maybe I want to continue at this point. Have I talked about continue and break yet? Thumbs up or thumbs down? All right. So what that means is just repeat the loop right dang now, right? Don't do anything after that. Okay, now that I'm at this point, the number has been converted to a float, but I don't know if it's positive or not. And if I don't indicate that it's positive, then it's just going to repeat the question. What's the number greater than 0? I'd kind of like to check and warn them that it has to be positive. So I think I'm going to add an if statement as one last little bit of information to them. If x is less than or equal to 0, it is going to repeat. We already know that because that's our while expression. But I want to print an error message as well. Error value must be greater than 0. All right, and now we're done. Now we have written some code that will not let them escape this loop until they type in a number that's greater than 0. We could find out if that works. I think I'm going to print a done message down here at the bottom just so that I know it worked and that it's not some kind of weird infinite loop. Oh, syntax error. That's because I used the wrong word, and I apologize. This word is what you use in C, C++, and Java, and a whole bunch of other languages, but in this language it's known as except. And I should have known, because that's not a yellow word there, or orange word, which means it's not a keyword. So change that word catch if you're playing along to accept. Hopefully I don't have any other syntax errors. All right, what's the number greater than 0? -1. Error must be greater than 0. I'm going to check my boundary condition. You always want to check your boundary conditions. 0. Error must be greater than 0. All right, what's the number greater than 0? I don't know. Value must be a number. Okay, I'm tired of taunting it. I'm going to give it a number. Okay, so that works. I've got a nifty piece of code here. What do I mean by nifty? Well, I don't know. That's like 8 or 9 or 10 lines of code. I wouldn't want to have to repeat that every single time I needed to ask a number. What if my program needed to ask the user for 18 different numbers, right? I don't know what, but I would want to probably make this a function so that I could call it, and it would, I could even put this function inside another piece of code whenever I wanted it. Just copy that function, paste it in there, and then I can call it just by using its name. I kind of feel like doing that. I'm going to turn this into a function. How do you create a function? What's the keyword? Yep, DEF. And I need a good name for it. Input underscore posnum. Parentheses in parentheses. Colon. Now I need to do two more things in order to get this to actually be a function. I'm not going to pass an x in, but I'm going to need, and maybe I misunderstood you, but I need, is my tabbing okay? No, my tabbing is not okay because I have a colon here. You always have to start. All right. So there we go. And there's one more thing I need to do here in order to make it a fruitful function. And what's that? You know, otherwise, if I'm down here and I want that number, x is equal to, you know, input underscore posnum, right? Like that. And then I print x. What is it going to print? Is it going to print the number that was typed in? No. So what do I need to do to fix that?
Return.
Right. I have to have a return statement to get the value outside of outside of our function back into the calling code. So I'll just do a return x. And don't be fooled by the fact that this is x and this is x. This variable is only valid from here to here. So, you know, if I tried to print x at this point, x is not even defined yet, except for the fact that it's defined up in the earlier code. But you know what I mean. The fact that this has the same name as this matters absolutely nothing because this variable only exists up through here. And once it leaves that function, once that function is done, the variable disappears. Except for the fact that we returned it. So good, we can catch it. But that's like getting a photocopy of it, right? If I don't do the return, then I took the paper and I just, you know, threw it away. You didn't get to see it. But I returned it, so I made a photocopy of the answer and I gave it to you.
So what is that? What exactly does return do?
What a return does is like, what if you tell me to go do something? You tell me to go to Walmart and get some milk. So I go to Walmart, I get some milk, and I come back and I just sit here. Are you happy with that result? No, you want me to give you the milk. That's why you sent me. And so return gives you the answer.
It takes out like it from the function.
Right, it gets the data out of the function. So if I did this, return 100, then after the function was called, this variable would be equal to 100. That makes sense?
Yep.
All right. Very good question. I'm going to test. There's no reason to test it. Well, I better make sure there's no syntax errors. I'm not even printing the version of x out after I get it, but it's there, trust me. So I've written a nifty little function that if I was a pro programmer, I might store this in, you know, in one of my own libraries, one of my own modules, so that I could just import that and call it whenever I wanted. Or I could at least cut and paste it into my new program. So anytime I wanted to ask the user for something, then I could do that. One more improvement to it, and I'm not going to go overboard, is maybe I would want to pass in the prompt. And what do I mean by that? Like, this doesn't describe what number we're looking for, right? It doesn't say whether, you know, it's a number of grams or, you know, the age or something like that. We might want to be able to do something like this, and I'm going to undo this, but enter grams of O2, right? Something like that. And we would like for this thing to print that out. In order to do that, we would have to have a parameter that would accept this argument. Well, heck, let's go ahead and do that. I'm going to leave that there, and I'm going to declare a parameter, and I'm going to print that out so that the user knows what they're entering. So print the prompt like that. So this is known as an argument, and when you pass an argument in, there has to be a parameter that will accept it. A parameter is just a variable that's defined inside the parentheses. If you don't have any parameters, if you don't put anything inside the parentheses, you better not pass in any arguments. But if you do have parameters, you have to fill them in. All right, now when it runs, it's going to ask for that question. Enter the grams of O2. What's the number greater than, all right, right. Maybe this, what's the number greater than O, then, right, that could have been worded a little bit more elegantly, like must be greater than 0, something like that. I'm going to change this just a little bit to reflect that. Must be greater than 0. How about instead of a question mark, because we're not asking them if it has to be greater than 0, we're telling them. All right, I'm going to pause it, and for those of y'all who are typing along, I'd like to make sure that you don't have any syntax errors. All right, well, it works on my end. Let's make sure it works. All right, for those of y'all playing along at home, what I did is after our math from math import star, I just added some comments to show those answers. Feel free to pause and ogle them, but we already went over this. Alrighty, I want to check something. I had some notice here. Alrighty, I apologize for this. This book different than the one that I used. So this book says that there's only 2 kinds of errors. That runtime errors and logic errors are the same thing. They're not. A runtime error is something that kills the program while it's running, but it might not be a logical error. Like what if you're trying to write to the Z drive, but there is no Z drive, right? Yeah, something has happened. There's no Z drive. A network mapping hasn't worked, or your network is down, or whatever. It'll blow up if you don't program it correctly. But that's not a logic error. It's just the fact that the Z drive was down. So that's a runtime error. And then a logic error is one when something is incorrect. It gives you the wrong answer, right? I ask it to calculate, the amount of oxygen produced by burning methane or whatever like that. And that's not right. That doesn't make oxygen. But anyways, right. How much carbon dioxide is produced by burning this stuff? And it always tells me 1. Well, that's stupid, right? It's not supposed to always return 1. That's a logic error. But the book says that a runtime error and a logic error is the same thing. So in the quiz, no matter what you answered, as long as you answered one of those 2 things, then you got it right. But I do want you to know the difference between a runtime error / logic error and a syntax error. The syntax error are these kind of things, right? And I've typed in something wrong, but there is no pprint function, right? Or I came down in here and I tried to, say, x is equal to y divided by a. And then I run that, I'm going to get an error here because it's probably actually going to be a runtime error. Let's find out. Yeah, that's a runtime error in this language. It wouldn't be in other languages. It would say that a had to be defined. But typos, mistakes, or passing in too many arguments, that would be a syntax error. Or not enough arguments, that would be a syntax error. Or, that kind of thing. Anything that's wrong with the grammar of the program is a syntax error. And according to the book, anything that goes wrong after you've run it, after it's been compiled and run, is a runtime error, which they skip parenthetically logical error. All right, so, and I've modified the quiz to reflect that. Feel free to take the quiz again to get more points. It'd be awesome if everybody took the quiz, 2 or 3 times to get 100, because a quiz is worth 1/5 of an exam. So hey, if you get 5 quizzes and you get hundreds on all of them, that's equal to 100 on an exam. So that's hopefully kind of cool. Alrighty, another one. Yeah, we've already talked about the random library, and we have just talked about using try, except. So I think we're good. While we're on this mode of free-form lecturing rather than looking at the web text or whatever, I want to talk about the OS library and the sys library. So up here at the top, I'm going to add something to my code. And even if you didn't do all that stuff, you might feel like doing this. I'm going to import OS. And, oh gosh, I've forgotten how to get a list of all functions in a module in Python 3. Forget it. I don't remember. It's something trivial, something super easy. But I have the OS module. I'm going to Google up what OS can do. So Python 3 OS module. Miscellaneous operating system interfaces. Miscellaneous makes it sound like it's not important, but it is. There's some good stuff in here. For example, if you want to find out what your current directory is, you can do git cwd. If you want to change your directory, you can call chdir. So like this, up here, I'm curious about what current directory I am in. So I'm going to type dir is equal to os.getcwd, which means get current working directory. And I'm going to print it out just for fun. Now dir is a purple word, meaning that it's a built-in function, so I better not use it. I don't recall what it is, so I'm just going to call it dir. Or cwd for current working directory. And then I'm going to print out cwd. And then I'm going to put an input here. Press enter to do other stuff, right? So that we don't have to keep entering numbers and stuff like that. Press enter to do other stuff. That's just a pause, right? Not stud. Stuff. So when I run it, I'm going to find out what directory I'm in. It says that I am in users JG Thompson desktop, and that's correct. That's what directory my scripts are stored in. But what if I don't want to be in that directory? Well, if I want to change to the root of C, right? Just like I was going to go out to this PC and find my C directory. However you do that in this particular version of Windows, right? And so, then I could get a list of the directories in there or whatever. I use chdir to do that. So, chdir C colon backslash. Now that backslash may cause us a problem. Oh, come on, where's my double quote? We'll find out. And then, yep, it's causing a problem. How do I know it's causing a problem? You can't see it very well, but that's green. What does that mean? It means that the string is not actually closed. I bet somebody knows why it's treating that as an error.
Because isn't that like an escape character?
That is an escape character. And so backslash double quote gets translated to just be a double quote. Now I could fix that. No, I can't. What I need to do is use 2 backslashes. Because this says it's an escape character, and this says, oh, no, it's not. Not really. I really need a backslash. I'm going to put a comment to that effect. Backslash is an escape char for a single backslash. All right, now if I do the same thing, I get the current working directory and print it out, it's going to say that it's C colon. I feel like just copying and pasting that text rather than typing it again. Save myself some time. Oh, boom. I did something wrong. Who spots the error? The error is this line right here. Yep.
OS dot.
Right, because the library is called OS, and I didn't say from OS import chdir or something like that. Right, I need OS dot there, because that's a member of that module. All right. So we've changed from that directory to that directory. Why might we want to do that? So we could get a listing of the directory. What if we were going to write a program that would list all the files in a directory, but if they wanted to change directories, they could do that? We could do that. That'd be kind of a neat program. We'd need a function that would return a file list. We could do that. Let's see what else is in the OS library that might be worth looking at right now. All right, I don't know what FCHDIR means. File descriptor, probably, whatever. FS path returns the system representation of the path. I'm curious about that. Yeah, I'm going to leave that alone though. Get environment variable. What is an environment variable? Well, your operating system uses things called environment variables to hold important information. For example, what is my computer name? It's BS-211-lab00, right? What is my app data directory? C users, J Thompson, app data roaming. So I could use that function and pass in this string, app data, and it would return that, so I would know what directory to save my app data in. Or, what is my home path, so that I could save things, into my home path. Something like that. So there's some cool stuff there. You can pull out any environment variable that is defined. The longest one is the path, right? And that's a huge one that's got all the search path that the operating uses to find a program when you run it from the command prompt. If I try to run Python from the command prompt, it works, but if it wasn't in the path, it wouldn't. And yeah, that was the whole point of that one. All right, so get environment variable, get login. Return the name of the user that's logged in. For most purposes, it's better to use getPass.getUser. All right, whatever. Okay, that's about enough of that. I don't see anything else in here. Obviously, there's lots of good stuff, but I'm not going to take the time to find something else that's cool. How about the OS library? Excuse me, the sys library. There's only one thing in particular that I want to talk about that's in the sys library. And I kind of need to make a little notepad of the functions that I liked out of the OS library. So maybe I'll just make a comment here. Functions in OS library that are cool that we demonstrated. Get CWD and CHDR. Okay. Just so those pop out whenever we review these notes. Alrighty. So import SYS. Now, what's the system directory good for? Well, we're going to use it to pull out command line parameters. Command line parameters, and I think I've mentioned this before, are if you type in the name of a program, and dir is its own program, right? I just ran it like that, but if I type in something else, like dir d star, it searches for everything that begins with a D. Well, that d star is a command line argument. I call them command line parameters. That's a little bit of that confusion between the terms argument and parameters. In this specific sense, I gave it an argument, but it fills in a parameter inside the program, just like any other parameter. So your program may need to be able to pick up command line parameters, command line arguments. Now, when we run a Python application, we do it like this: Python followed by the name of the application. Like if I had a program called T, then I could do Python t.py and it would run it. I don't have a program called T, but I have a desktop directory. And inside that desktop directory, I have some scripts. I'm not going to take the time to do that. We learned a cool way of opening a command prompt in a specific window, which is to click up here. And I'm going to go into my directory first. Desktop, scripting, and then what do? How do I get into the command prompt in this particular folder? We've talked about this. Nobody remembers? That's okay. What I do is I cover that path. I type in CMD. It runs the command prompt in that specific directory. Now if I do a dir start.py, I'm just going to see a whole bunch of py files. That's cool. I'm going to run one of them. Py python space lecture j.py. And it does something. Yeah, it runs my program, right? I told it to change directory to C:, and press enter to do other stuff. All right. So anyways, notice that it didn't permanently change my directory. It didn't get me out of it. The command line, the command prompt is still where it was before. But as far as the program was concerned, we were temporarily in C:/. But what if I needed this program to take an argument, like a path that I wanted it to change to? Not just C:. C:" could be the default. But if they don't have a default, what if I want to run this program, Python space, and I think I'm going to create a maybe something that's got a little bit better name because I'm getting tired of typing Python lecture J like that. But anyways, so I'm gonna create a new app just to give it a super short name. I'm going to give it the name of hello. That's trivial. Hello.py. And I'm going to import sys. And once you import sys, you can get out the command line arguments. When you import sys, you actually get a list of command line arguments. I can just print them out. I'm curious about them. So I'm going to print sys. Excuse me, I typed that wrong. Sys.argv. And that should display a list of all the command line arguments. Now, if I run this from idle, there's not going to be a whole bunch of command line arguments. There's only one. It's the name of the program. That's kind of useful. So, if I cared, program path, or ppath, whatever, is equal to sys.argv subscript 0, because remember subscript 0 is how you get the first element of the list. Now what if I go down here and I run it from the command prompt now? And so okay. Maybe I can change the font size, make it a little bit easier to read. Really? All right, fine. Hope that's easier to read. Okay, so I'm going to run that program now. It's called hello. Python hello.py. It says hello.py. That's the name of the app. And then Python hello.py, and I wanted it to say my name. There, check it out. Jeff. That's my name. I passed it in as an argument, and so we have that added to our list. What if I do Python hello.py and I give it two names? See what's going on? Each additional argument I give it is added to our list of arguments. So I could pull that out, and I could pull that out as well. So what I'm going to do is I'm going to have it check the number of command line arguments. And if it's not right, then I'm going to yell at them and tell them that they need to enter both the first name and the last name. But first I'm going to find out how many command line arguments they gave us. Let's just check the length of that list. Print len of sys.argv, right? Just because I want to see how many command line arguments were passed in. 1. Well, it didn't seem like I passed in any, but by default there's always one command line argument, which is the path. So what if I run this from the command prompt? Did I close my command prompt? Dadgummit. Well, it's easy to get. Come up here, backspace, cmd. Now I'm back in the correct directory. So when I run python hello.py and I give it a name, it tells me that I have two arguments. So if I gave it a first name and a last name, how many arguments are there going to be?
3.
Yeah, there's going to be 3. And let's prove that. Python hello.py Jeff Thompson. There are 3 command line arguments. And which one is my first name? What's the index number of my list for the element that has my first name?
1.
Yep, that's 1. And I only hear one answer being given, and then one answer that I'm being given is quite correct. But that's element, and I don't want you to stop, but that's element 1. And so that's index value 2. So the first thing I'm going to do is to make sure the number of command line arguments matches 3. And if it doesn't, I'm going to tell them the syntax. And then if it is 3, I'm going to go on and I'm going to pull out the first name and the last name. So now that I'm here, maybe I don't need to print that out anymore. Or maybe I could give it a little bit more text. Number of CMD line arguments equals, end quote, comma, right? Something like that, just so I know what that actually is. Okay, so let's check. If the length of sys.argv, in parentheses, well, that's not quite right, is not equal to 3, colon, we're going to give them an error message. Print syntax. Python hello.py first name, last name. We're telling them exactly what they did wrong, or exactly what we're expecting. Else, now here's where we're going to do some good stuff. I want to get the first name and the last name in. And the first name was stored in that in element number 1, index 1, and last name is in index 2. So fname is equal to sys.argv. I'm kind of wishing that I'd done an import or from import, you know, get argv or whatever, so I wouldn't have to keep typing sys. But anyway, sys.argv, subscript 1, that'll be the first name. And an L name, that's a L and not a, you know, a 1, is equal to sys.argv2. Now I have the first and the last name, and I can print something out. Print hello, comma, end quote, comma, fname, comma, lname. That's enough. I don't need to do anything more than that. It just proves that it works. And then down here at the bottom, I'm going to print, okay, all done. And then maybe I'll add a print message. Press enter to finish. Make that an input. Input parentheses. Press enter to finish. Or return, whatever your favorite word is. Okay, so when I run it from idle, I'm going to get an error because I could not pass in my first name and my last name, right? Maybe there's something in the options that would let me do that. But it yelled at me. The syntax is, it yelled at me. So I'm going to try running it from the command prompt. And it looks like, yet again, I closed my command prompt. Window, backspace, CMD. All right, so I'm going to run it now. Python hello.py. And it yells at me. The syntax is Python hello.py, first name and last name. So now I'm going to do what it wants me to do, which is give it that information. Python hello.py, Bob Johnson. And it should say hello, Bob Johnson. So you can do all sorts of different things with command line arguments. And as you go on and you take other cyber classes, then you'll need to know how to pull in command line arguments into your program to inspect them. They might be passing in a username or a file name that you're supposed to edit, or, you know, some value that you're supposed to translate from one thing to another. So I hope that makes sense. If it doesn't totally sink in, that's okay, but I want you to have the idea in your back of your head of what a command line argument is. Command line argument is something when you give it a program name, but then you give it additional things to tell it what to do, right? And that your program can pull those out. And if you need to do that, you can always Google it. Google space command line arguments Python 3, and you'll get a nice snazzy example of how to do it. All right, that's about enough. I will pause the recording. I will walk around and make sure that everybody who wants it has it working, but I also want to make the directory first.